I want to welcome all of you to this session of Generative AI Agent class. This had been a series that I've started since 2025, and this is just one part of it for this year, and I welcome all of you. My name is Joseph Osumeje. I'm from Nigeria, but I'm currently a Schmidt AI in Science African Faculty Fellow under the Midas program here at UMich. And my colleague here is Dr. Nazreen. She's a postdoctoral fellow in the Biomedical Engineering department or school. Today we are just here to give you an idea of what generative AI is. I know you're all from different backgrounds, different fields. Could be the sciences, could be the engineering, or maybe you are just inquisitive about AI and, in fact, agentic AI. I welcome all of you to this class today. Before I get started with this session for today, I would like to maybe ask a quick question. How many of you have used ChatGPT in the last week, or Cloud, or generative AI? Just a show of hands. Okay, that's interesting. So it's like we're all in the field of AI in one way or the other. And I want to give this as a follow-up question. What really happens if you close the app? Say, for instance, you close your your ChatGPT, you close it. Does it really do anything for you after then? I assume no. That means such kinds of models are just passive. They hardly do anything after you close the app or you shut your window. Today we're going to bring to you a new idea of what the power of AI agents is. We're going to talk to you about how it works, how it gives you results, how it manipulates itself to give you, to answer your tasks and give you the outcome that you desire. If you have any question along the way during this talk, please feel free to indicate by raising up your hand. In case we are going too fast, please tell us that we're too fast. As much as possible, we want to carry everybody along. If we are going too slow too, please remember to tell us to speed up. We know time is precious for everyone here, and then we want to make your stay here worth the while. We want to start with the agenda for the day. We will actually talk about what is an AI agent, the basic concepts, and then definition about what an AI agent is. We will talk about single AI agents, which is the think, the act, and the observe loop. This is actually the framework on which every other agent is actually built upon. The think, the act, and then the observe loop. We will talk about how do generative AI agent work. We're going to talk about their tools that are made available to them, their reasoning capacity. We're going to talk about the components of this generative AI itself, one after the other. And then we'll talk about multi-agent system. This happens when single agents work together as a team. I want you to picture it in a way that you talk about a solo artist that is being transformed into an orchestra system of artists where they work together in harmony. Then we'll talk about the hands-on demo, try to see how we could build a generative AI in real time in this class today. And then finally, the Q&A session, and then we're going to see how much knowledge we have tried to impact in this short period of time. So let's start the ball rolling with what is an AI agent? I'm sure this had been the mystery word that has brought all of you into this class today. An AI agent is a system that can act autonomously to achieve goals. It perceives information from its environment, makes decisions based on that data, and then acts or takes action that will change its environment or move closer to a goal. This is actually what an AI agent is all about. But I want you to picture it in this way. A vacuum cleaning robot is a very good example and a perfect example of what an AI agent is. This robot goes around the room to clean your environment. It picks up dirt as much as it senses where a dirt is, it goes after it. But the ability of it to control itself when it gets stuck or stumbles on furniture or items in the room, the ability for it to take a decision whether to turn left or to turn right. That is the knowledge of what an AI is all about. And then also its ability for it to go and dock to recharge itself when its battery goes low is another good idea of what an AI agent thinks or works like. And then if it docks, as it charges, it tries to observe its environment to see how neat is my environment like. Are there debts that have been accumulated over time after my docking process? And if it detects or identifies such, it goes back into the environment to do that same process. And that is the loop that it carries, or that is the loop that it does over and over again, just to keep or to answer the task of keep my environment clean. And now, the simple idea of how, which I said is the framework of generative AI, is that your AI agent thinks about the task at hand. It analyzes all the information available to it, and then it acts based on the tool that is made available to it. Tools could be like search engines, calculators, mathematical operators, or scripts that are made available to it. And then it uses these tools in real time to bring out information for you. And this information information that it had gathered from the real world. And that means it brings out, the task is being done actually based on real-time data. It extracts this information with the tools, put them together, and then gives you an outcome. And then it observes the outcome. If the outcome is as much as possible close to the task that it's supposed to carry, and then it gives you your final result. If it is not satisfied with the outcome, it goes back and performs the same loop again. Now, let us try and differentiate what we mean by these three terms: generative AI, a chatbot, and an AI agent. I'm very sure most of us, or all of us here, are familiar with the term generative AI. Generative AI is actually the large language model, which is actually the brain in modeling. This works in such a way that it has a one-way short-in answer, a question, and then a one short answer out. You ask it a question, and it gives you answer. And that's all it does. After that, there is no action that takes place behind the scene. This is how the ChatGPT, the Gemini, the cloud, this is how they work. You ask them question, and then they give you the response. Then the chatbot. The chatbot goes a little step ahead, such that it can keep conversation with you. The difference between that and a generative AI model is that the chatbot can remember short conversations that you've had with it over time, maybe like 2 or 3 conversations previously, and then it continues that conversation based on those knowledge of information that it has with it. But after that, it doesn't do anything behind the scene. It doesn't act for you. It doesn't act on your behalf. It doesn't carry out instruction once you close it up. Then comes the agentic AI or AI agent. The AI agent is quite different from any of these two in the sense that it has its autonomy. It works independent of the presence of the user, independent of any instruction from the user. What the AI agent does is that you give it a task, it will create its own path, step-by-step plans of how to execute that task. And then it follows that task based on the availability of the tools that have been given to it. It decides when to pick which tool at any time at its own discretion. That's the beauty of it. It doesn't have a script that tells it, use tool 1, else go to 2. There is no such statement that it works with. It creates its own sequence of steps that it has to follow based on the task given to it and based on the assignment that it needs to deliver. That's the difference between the generative AI agents and all other agents, AI models. And so this big gap, because it might look small, but it's actually a big gap, which is a big difference between what we are used to in the generative world and then what is trending right now in the AI agentic world. This is a simple sketch of a single AI agent with all the components. My colleague will talk much in details on this, but I want you to have this picture. The user inputs a task in form of give me or I need so information or carry out so assignment for me. And then the AI agent perceives these tasks, gathers general information that are available to it, look for ideas or information that are on ground on such kind of tasks. And then he thinks about the easiest steps for it to be able to achieve these tasks. It plans its own track for it to follow to achieve this task. And then when it is satisfied with those steps, it now applies the tools that are available to it. The AI agent does not go beyond the tools that you make available to it. And so if you ask it to do a particular task, it works with the tools that are available to it. We should be cautious of that too. So it recalls the tools that are available to it to execute these tasks step by step and one after the other. And then once it is satisfied, it creates an output and then evaluates the output to see, am I close to the task or have I achieved the task? If it is not satisfied, it goes back the loop all over again to carry out this process one after the other again, but in a quite different step-by-step route for it to follow again. And then at the end, if it is satisfied with all requirements to give out a perfect output, it gives the client its outcome. And that ends its own task. The beauty of the AI agent is that it's unlike the chatbot that just talk. The AI agent does give or does its work. It produces for you an outcome as a result of its action. It produces for you a result as a result of its action. At this stage, I want to step aside from my colleague, Dr. Nazreen, to continue on this conversation. If you have any question, please. Thank you, Dr. Nazreen.
Thanks, Joseph. Hi, everyone. I'm Nazreen Pallikkavaliyaveetil. Sorry for my long last name. I'm a postdoctoral research fellow at the Biomedical Engineering Department. I work under Dr. Sriram Chandrasekharan, and I'm a deep learning researcher working in drug discovery. So welcome to the talk. So I'll continue wherever Joseph stopped. Thank you, Joseph, for the introduction. Let's go to the next slide. Okay, so now Joseph told us the high-level picture of what is a single AI agent model, right? So a single AI agent model, irrespective of the frameworks that we use, is composed of certain components, like basic components. And these are the basic components that composes a single AI agent model. So the first and the most important component is the brain, which is a large language model. Now, a large language model is, as you might be knowing, that it's a transformer-based model that does next token prediction. So given a prompt, it actually does a next token prediction based on probabilistic assumptions. So that's the main component of any single AI agent model, and we call it the brain. So once it receives an input from the user, it's the brain that reasons with this input or the context to determine what task is to be done and how it can be executed. So all the thinking part is done by your LLM. Now, this LLM decides what tool or actuator is required to act on this prompt that the user has given. So given the context, the large language model decides, okay, the user has asked me to do so, and I don't have that information, so let me grab a tool or an actuator that does that for me. So that's the second most important component of an AI agent, which is the tool or the actuator. And it can be anything like a search engine or an API query. It could be a user-defined function like a temperature conversion, or it could be anything depending on the task of your AI agent. Another optional component is the memory component. The reason why I say is optional is because many small AI agent models don't have this memory component, as this is computationally expensive. So the role of the memory component is to store all the past information or the iteration details that the AI agent has gone through, and it is very helpful to do, help with the next iteration or to decide what to do in the next iteration. So in this workshop, we will be talking about a stateless AI agent. So that means it does not have a memory component, so it does not have long-term memory. And the next component is the control loop. I'll talk in detail about that in the next slide. So it's just that AI agent doesn't do things in just one go. It's not like there is input, there is LLM, then the tools, and there is output. That's not how it works. There's always like a loop that's going on, which is called the control loop. And the control loop is actually determined by the large language model or the brain of the AI agent. So in a nutshell, we can say that an AI agent is a model that can not just think, but also act on it, right? Okay, so let's look how an AI agent model works. So the way an AI agent works is using the think, act, observe loop. So the first thing it does is, let's say a user is asking an AI agent, for example, the temperature of a particular city. Let's say it's and give me the answer in, let's say, Fahrenheit. So the first thing that the LLM is doing is grab the context, and try to reason with it and say, okay, this is what the user wants me to do. And do I have that information at hand? So the thing is, a large language model does not have such a tool to execute it, right? So then the next step is it needs to find the appropriate actuator or the tool to get that information. And so that's the next step, which is the act step or the action phase. Now in the action step, the large language model, decides I need to find the temperature of this particular city, and I need to grab a tool that can help me do that. And so it grabs a tool to execute that. And once it gets the temperature, let's say the tool is giving the temperature in degrees Celsius and not in Fahrenheit. So that's your observation during the first loop, during the first iteration. That is the temperature of a city in degrees Celsius. Now, this observation, it again goes back to the brain of the AI agent, which is the large language model. The large language model looks at this output, looks at the context, and compares the two and says, okay, I have this information. The user wants me to get the results in Fahrenheit, which I don't have. So I need to grab another tool that can do the conversion. So the next step, The next step it does is grab a tool that can do this temperature conversion. And once it gets the observation from that, then the LLM again reasons with it, and it's like, okay, I have the information what the user asked me to do. And it stops there. And as you can see, this iteration or this think, act, observe loop is actually done dynamically, unlike any training or inference of deep learning models where we set a fixed set of iterations. This doesn't happen that way. It actually depends on how the large language model thinks it through and how, what is the output that's obtained during each iteration. Yes. So now we have covered what are the components of an AI agent and how an AI agent works on a very high level. So if anybody has any question at this point, please let me know. Otherwise, we can go to the next slide. Yeah.
I get so confused with U of M GPT. Is that considered an agent or a...
Right. That's a very good question. So essentially, a large language model is not an AI agent. It's just a deep learning model that can do a next token prediction. But most of the advanced GPT models that we have right now, for example, ChatGPT, Claude, or U of M, for example, it can actually access some toolboxes, like a limited amount of tools, not toolboxes, I'm sorry, tools, like search engine, for example. So it acts like a small AI agent, the ones that we have currently. But a large language model, as such, is not an agent. It's just a deep learning model. Oh.
They seem to be able to track information from prior sessions even after you log out.
Mm-hmm.
Yeah, but you're still not considered an agent.
So that's like the one that I said, like the memory component, the state space machine model, which can actually keep track of whatever prompts you gave, the user gave during that session.
And even prior sessions.
Yeah, even the prior session. So for that, you need really high computing resources to keep track of it, or to store all that information and retrain your model. Yes. So now let's see some of the tools and frameworks that are available for a researcher for building AI agents. Now, there are so many toolboxes out there, so we won't be able to cover everything, but I'll just give a gist of a few toolbox and frameworks that is available out there for us to build an AI agent model. So the first thing that I have highlighted is a small agent. The reason why I have highlighted it is because it's used in this workshop, and it's part of the Hugging Face ecosystem. One of the advantages of small agents is that it's pretty easy, and it's a lightweight framework to plug and play different components of an AI agent, such as grab a large language model, grab all the toolbox and connect it together. So it's kind of much more easier and a simplistic framework by Hugging Face. The other one is OpenAI API. It's actually an open source platform by OpenAI that provides trained large language models for you, that is the trained brains for you. So it's providing, let's say, GPT-3 and newer versions, which is already pre-trained models. Now, one caveat here is that the user will have to write extensive codes here to build your own AI agents, to grab these large language models and then connect your tools together and implement the think, act, observe loop. Now, the third ecosystem, similar to OpenAI, that provides a pre-trained large language model is the Hugging Face ecosystem. It's also an open source ecosystem. Now, Hugging Face actually provides a lot more pre-trained models, not just large language models. You can also find other trained deep learning models, let's say ResNet or CNN models, UNets, etc. So this ecosystem can be used to grab large language models such as Llama 2, Falcon, etc. And one of the advantages is that, like I mentioned, it also offers frameworks like small agents, which you can use to, construct your AI agent models. There are several other frameworks such as LangChain, AutoGPT, Baby AGI, Llama Index, and LangGraph. Now, the main trade-off will be like some of them would be, lightweight, some of them would be autonomous, some of them could be like easy to implement. So the trade-off varies. But the key takeaway is that regardless of the framework, the basic core components of the AI agent, it remains the same. It will be like there will be a large language model, you have your tools, you have your memory component, and your think, act, observe loop. So these are the main components of the model, irrespective of your framework. Now, let's look at how we can interpret when you're building an AI agent. So there is a way the user can actually see the intermediate steps of an AI agent. That means what are the steps an AI agent is taking during its think, act, observe loop. And you can always use a verbose or a debug mode for that. We won't be covering that in this workshop, but I just want to let you know that that's always possible when you're building your AI agent model. For example, let's say someone wants to know what's the capital of the country that won the 2018 FIFA World Cup, right? So the first thing an AI agent does, it divides the prompt into smaller units. So the first thing the large language model sees is, okay, I need to find who won the 2018 World Cup. And then it uses the tool, let's say a search engine, to find that. And it gets the observation, which is France. And once it gets that observation, the large language model looks into it. It's like, do I have the information that the user asked me for? It does not. So it knows that it has to go back to the think, act, observe loop, and it grabs another toolbox, which is also a search engine in this case, to get the capital of France, which is Paris. You can always look at these intermediate steps and make sure that your single AI agent is going in the right track to get the required output that you want. Okay, so we have covered most of the important details of single AI agent models. Now, if you have any questions, please let me know. Otherwise, we can go over to multi-agent systems. Yep.
Would you be covering its like limitations and then also security concerns of when you get access to different tools?
Yeah. We will. Yeah.
Can you just repeat the question? We just couldn't hear. Yeah.
Repeat the question.
So she was asking, will I be covering some of the, I guess, considerations and limitations, right? So we'll cover that briefly, but not too much in detail, but yeah. Okay, so now let's look into multi-agent systems. Oh, sorry.
I have a question regarding, I'm wondering how they decide whether to use a tool or just use pre-trained text to answer the question, because like, what's the capital of the France?
Right.
They can use search, web search, and they can just retrieve the answer from their pre-training data.
Yeah.
So how do they decide?
Actually, it depends how powerful your LLM is, essentially. If you're using, let's say, GPT 3.5, I guess you will already have that answers already trained. Okay. So it essentially depends on what.
So they know their abilities to answer certainty on the
it actually depends on the person who is building the AI agent. Let's say the researcher who is actually working on it. It's upon his discretion how powerful. And usually the AI agent won't be used for such simple tasks. It will be more complicated task. I'm just giving a simple example.
Maybe let me add one more cases to say that if you want to like let your AI tell you like what's the weather for the location, for example, Paris today, and then
I'm
this
sorry,
is sometimes.
there's a lot of us back here. Would you just mind speaking up?
Oh, sorry. So, yeah. So, for example, if like we want LLM to tell us like what's the weather in Paris today, And usually the pre-trained large language model will not be able to answer that. And in that case, maybe you want a tool to call and then to inquiry about the weather at this time and then tell you that. And otherwise, like, if you are thinking about like some general knowledge outside, maybe you want to use.
Yep.
Yeah, just follow up on that answer. I feel like maybe there is another screening phase, like to delegate which kind of question I can answer.
Yeah, so
through the pre-training and which kind of.
Yes, that's correct. So the LLM actually thinks, does it have the answer right now? And then it goes on to grab the tool.
Thank you.
So let's go to multi-agent systems. Now, multi-agent system is a collaboration of single AI agent models. So just like any, let's say, a research group where there are multiple researchers from different backgrounds. Let's say one person is a computer scientist, the other person is a biologist, the other person is a clinician, and they all work together for an interdisciplinary project. A multi-agent system is very similar to that. So it has different single AI agent units coordinating together for a certain goal. Now, each of these single AI agent unit has its own core components, that is its own large language models, its own tools, and its own think, act, observe loop. But the key is that they all coordinate together for a certain goal. Now, the large language models in these different AI agents, it can be the same large language model, or if it's a highly complex multi-agent system, it could also be different. For example, let's say one AI agent is having a large language model which is trained purely for images, or the other one is trained purely for, let's say, text or something for bio-GPTs. So it could be as complex as that as well. Now, let's see how a multi-agent interaction happens with an example. So let's assume that you have two AI agents. One is a researcher agent, the other one is a writer agent. Now, the writer agent's focus is to generate a clear, well-structured response and information. And let's say it's acting as a coordinator, which is at the front end. But the writer agent has only the tools that is helping it to write a structured paragraph. So let's say grammar check or spell check, etc. And let's say there is a researcher agent which can actually grab informations and get factual information that's required for the writer agent to do its task. So let's assume that the user wants to know how rainfall affects forest ecosystem in simple terms. So at the front end will be the writer agent, and the writer agent the brain of the writer agent looks into this query and it's like, okay, I don't have the information that's required to write such a paragraph, right? So then it delegates with the researcher agent, which is equipped to get those factual information. The researcher agent gets all the factual information that is required, such as, let's say, supports tree growth, nutrient cycling, too little rainfall causes drought stress, too much rainfall causes, flooding and soil erosion. So all this information is gathered and it's sent back to the writer agent. And the writer agent looks into those informations and sees, okay, I have all the information that's required for me to write a clear, well-structured paragraph, and I also have the necessary tools that's required for writing it properly. And then the writer agent writes it and gives it to the user. Now, this is a very simple example. Future multi-agent systems can increasingly engage in dialogue, negotiation, critique to improve coordination and output quality. There is a lot of research going on in this field as well. Now, let's see some of the best practices and considerations for agentic AI. Always start simple. Let's say when you are building a multi-agent system, for example, make sure that you make your single AI agent system perfect and that it's working properly. Choose the tools carefully. So you don't want to confuse the large language model. So make sure that you only add the required tool that is required for that particular single AI agent. Also, inspect the reasoning traces. Like I mentioned, you can always have a verbose or a debug mode on while developing your agent to make sure that the agent is actually going in the right track when it's given a query, and it's not just picking up random tools for doing random things. And always test incrementally. So when you're building a single AI agent, make sure that you are adding tools incrementally. Similarly, when you're building a multi-AI agent system, make sure that your single AI agent systems work properly. Now, some of the consideration is hallucinations can still happen, as large language model, like I mentioned, is just a next token prediction model. So it's predicting things based on probabilistic prediction. So it can still hallucinate. So you might have seen ChatGPT going crazy sometimes. So that can still happen. So keep a note of that. Keep that in mind when you're building the model, and make sure that you test it when you're building it. Another consideration is cost and latency. So more tools you add is the more compute cost and more time that is required to execute it. Similarly, when you are adding, when you have to, let's say, fine-tune your large language models in between, that also increases the compute. So keep that in mind. Now, multi-agent systems complexity, it grows fast. So one thing that to keep in mind, just like any research group, for a successful research, we need proper communication. So we need proper communication between single agent models. We need to make sure that two different agents are not going in two totally different directions. Otherwise, we'll get errors in your output. And one of the most important considerations that I would say is ethics and safety. So let's say you're building an AI agent for real-world applications, let's say such as making transactions or sending emails. Make sure that there's always a human oversight, and also make sure that you are training a large language model which can actually say no to unethical queries or questions. So that is one important thing to keep in mind when you're building your models. Okay, so I think we have covered multi-agents and single-agent systems. So if you have any question at this point, please. Yeah.
Thinking about how we can evaluate, first of all, how to evaluate the multi-agent model, and the second question is how we are going to ensure the privacy of the information.
So that's a very good question. Now, evaluating, like I said, it's up to the user's discretion. So it's like you have to have a debug mode on to see what are the intermediate steps the agent is taking when you are building your model or when you are fine-tuning and training your models. That's very important, and that's a way to evaluate it. But still, like I said, there is a possibility of hallucination because no model is perfect. So there's always a possibility of hallucinations in large language models. Sorry, I forgot your second question.
So privacy of
Yeah, the privacy also is like, it's also like dependent on who is, building and giving the model out there, putting it out there. Let's say if the model privacy is set that any user prompt is used for training the model again, I won't call it a good model because that's clearly a privacy breach. So there should be certain a stateless model somewhere inbuilt so that it can clear those data, or it's not using that data for training or fine-tuning your models again.
It's just like, maybe I should add further to it. If you use some of these LLM, like Gemini, and you ask it for some private information, it will give back to you that I can't access such private information. So those are some limitations that you could, restrictions that you could give. You cannot access private information of the individual unless you are permitted. So unless you give it permission to access maybe your private information, it goes ahead to it. But public private information is the limitation.
So why I was asking is like I'm kind of like a data scientist studying a lot of health data. So with respect to health data, I need to access the health data if I am going to build an agentic model to do that analysis, right? So in that case, I have to give permission to the health data. But then how I will respect the privacy of the patient records?
Well, I'm sure you get some ethical clearance for such kind of research. And so information that are supposed to be made public could be available for such agents. If your ethical clearance restrict you from publicizing such personal information, I'm sure you would not include it in your AI.
We cannot build an AI agent for those kind of
You could.
Yeah.
You could, but you have to give it the permission to go beyond anything that is private.
Just to add to that, so just especially since you mentioned health data, there's a concept called federated learning. Let's say if you have to share informations between different research groups and stuff, there is actually a way you can just share the weights, not any other informations, weights and your parameters. And the concept is called federated learning. Maybe you can check that out. So yeah, that's most widely used in clinical field actually.
follow-up question, sorry. So, if you're trying to make a multi-agent model, right? So, a particular model is capturing a clinical side of the health data, and the other one is capturing the epidemiologic side. So, if, for example, I am from a particular group, I want to work with another agent built by a different expert because I'm not having the knowledge of that
Right.
agent because that's a different field for me. Like for example, clinician. Clinician will have a different model. So if I'm going to collaborate,
Yeah.
is there possibility to have a restriction that only both of us can share the data together? Can we do restricted agentic model? I'm sorry.
I mean, I think that depends on the ethical clearance. I don't think it's more model dependent. It's not model dependent. I think it's more, like Joseph mentioned, more sort of an ethical clearance between the team.
But then can we both use that data to build the agentic AI and restrict it within only our group or something? Is there any possibility like that?
So, you, yeah.
Instantly, so if you want to solve this in a single shot, you can use local models. The data is located in your server, in your machine.
Yeah, I wanted that element. So we have this local element, we have the department-specific or the field-specific information, so we can use that to build our agents.
Yes, that would be better.
Nobody can access that.
Okay, sorry to interrupt. I think maybe we can take the rest of the questions offline. I just need to finish this so that Joseph can show the rest of the workshop. Okay, so now before jumping on to the workshop, the code, I just want to give you guys a heads up on what to expect. So we are not training any large language model. We are not fine-tuning any large language model in this workshop. We are just grabbing an already trained large language model from Hugging Face. We are running everything on the Hugging Face cloud for this particular collab notebook. For accessing this large language model, you might have received an email. So you need a personal access token so that you can access the Hugging Face large language models. And the token can be stored safely in the collab secrets. So like I mentioned, large language model is running on the Hugging Face cloud. Agent logic such as code agent, it's running on Colab. Tools, the ones that we are using right now, it's actually running locally in Python, so we have built-in functions for that. And since we are not training any large language models, here we are not using any GPUs. We are just using Colab CPU for this workshop. So the key takeaways is AI agent is LLM that can actually act. The core components are large language models, the tools, and an optional memory component, and it does a think, act, observe loop. There are a lot of building frameworks that's available so that one can build their own AI agent models. Now, multi-agent systems, just like any research team, it's a collaborative model of AI agents. Now, keep in mind that always have a responsible innovation. So test and monitor the agent's behavior, have a verbose mode on, and keep exploring. And we will see in a couple of minutes the Colab notebook. And thank you for your attention. Just a couple of more slides. So in 2025-26, Midas is offering a lot of cool generative AI tutorials. So just look into this. You can scan this QR code and see what is available for you. And there is an AI in Research Symposium coming up, which is March 30 to 31, 2026 in the Rackham building. So keep an eye on that as well if you are interested. And these are some of the hands-on AI for research that is offered by Midas. Please go to the Midas website and check it out. Yeah, thank you for listening. Thank you so much. So I hand over the mic to Joseph.
Thank you all for your attention on this. I think we have to go straight ahead to our Google Colab. And so if you have gotten the email, I'll request you at this time to try and access the email, open your Hugging Face account. I'm sure by now you should have created a token that you would use. If you have not done that, please use this time around to create your token and make it available for the next step.
When was that email sent?
Okay. The email's supposed to have been sent earlier this afternoon.
Who was the sender?
Okay. Let me make some verification, please. Kelly.
Okay, so you should have got an email from Sessions if you signed up on Sessions.
That's the presentation.
Yeah, it's presentation only.
That's the 30-minute one.
I only got that one.
Yeah. So sorry for the confusion. It should have been like a subject title, see you in 30 minutes. That's the presentation.
That's the presentation.
Your session is happening soon.
Oh, but it's
Yeah.
in the other sessions one that came.
So you're looking for the slides for today? I linked it in the...
Days ago?
So I found
Your session is happening
your
soon.
session is happening soon, and that has a different...
Yeah, it says we look
I-
30 minutes.
2 days ago, you sent one. It had sessions is happening soon, and it was 2 days ago, and I see a Hugging Face there. And then
Oh,
I had to
okay.
look for
I sent one
session-
30 minutes before the event started saying, see you in 30 minutes.
And that had the presentation.
That had the presentation link in it, so I wonder if it's still...
I see it in the other one that went 2 days ago. March 17th, yeah.
Okay, okay. I will resend it, maybe for my personal email. Sorry, everybody.
No worries.
Sessions told me that it sent it
Let me see how the Colab so it shows.
personally.
Last one I got was from January 20th, and then one from today.
You want to draw it outside? Yeah. But it just took a couple of days.
It's the Hugging Face huggingface.co/.
Yes, and then you would just.
Is it just a matter of just the link to sign up to Hugging Face?
Right, right. It's just this much.
We see where there's something else.
Okay, I mean, I could do that. I'll email.
You need to have a account first and then generate the.
Oh, sorry, they even say that. Oh, okay. I need to log in.
Can anybody tell us how to create a token? Once you're logged in,
Can I have your attention here, please, if you want to create your Hugging Face token? You can log into your, once you log into your Hugging Face, you go to Settings. And then you click Access Token. Access Token. I already have mine here, so let me delete this.
It's here.
Okay. Okay. You have create a new access token. Okay. Are we all there?
Yeah.
Okay. Then you click this icon here. Read. Okay. Then you create a token name, something that you can remember. Just any name.
How can we create the token? I'm at the Hugging Face website, but I don't know where it is.
Okay. Once you input the name, your token name, and then you just click Generate. It gives you, it prompts out a dialog box like this. So this is your token, this long alphanumeric there, that's your token. You can either copy it and save it somewhere else, because once you close this page, this dialog page, you can't access it again. And so you can copy this, and then I don't know if you've gotten the email right now for the Google Colab page. I just sent out an email to all of us here. And so if you go back, if you open your Google Colab.
Can I ask a question?
Yes, please.
Go to the beginning of the first page of the HUD page of the personal and just kind of step.
If I close this page, I can't have access to it again.
Okay, so I guess it's hard to see back here, because are you on Hugging Face now?
Yes.
And how did you get to that? I mean, 'cause I see.
Nazreen, please can you put her through? Sorry. You sent it to me. Okay.
Okay, I just sent an email with the links, let me know. You got it. So if you get your session is starting in 30 minutes reminder, like a day or two from now, just ignore that. It must be running behind. Did everybody get the email?
I'm with you.
Okay.
Okay. It's traveling far.
Okay. I could demonstrate with my own Google Colab here, but as much as possible, I want all of us to go together so that you appreciate it better. And so if you have gotten the email, please can you open the Google Colab.
Everybody get it? Okay.
Okay.
What permissions do you set for your access to
Read.
For which one, the presentation or the collab? All right, hold on. Nathan's got the magic
Okay.
part.
JOSM.
This said,
Try refreshing. And then there should be buttons that say you. Oh, they have a blue selection.
is everybody able to access it? It okay? Okay. Thanks for your patience.
I don't know, maybe they will.
Say again, please.
So you had your token up right a minute ago, so now are we supposed to sit done?
No. You have to copy it first. Okay. Then you go to your Colab page. You have two options to this. It's either you click this first, and then the next box here to run. At this stage, it's at this box here is going to tell you to input your token, or you could go to this key sign here, key symbol here. There's this key symbol here. You click it. You click it, and then you add a new secret. Are we all there? Key symbol here in your Google Colab page. Yeah. Once you click it, you would add a new secret. You type in the name that you've given your Colab, and then you insert your token key here. Type in the name that you gave your token that you generated in the Hugging Face, and then you paste the token value here, and then you activate this icon to give it access. No, the name that you created on the Hugging Face, the exact name. Yes, the token name. Frank. I've not sent the email. Yeah. Is it a chat? Oh, okay. What was the name you used?
Which name for the token? It's like one of my new Gmail.
Okay.
Yeah. Do you need that?
Yeah, well, I was thinking, anyway, let me just copy it here.
You can first try and
I have a question.
Okay, okay, please.
It seems in the step 2, it says like the name should be Hugging Face token, and a secret named Hugging Face token.
Yes, but that's the name that you used to create the token. Hugging, it should be. Okay. So the name here should be.
I think it should be HF_token.
Yeah, please write HF_token under the name here, please. HF_token.
Because I tried that one and it didn't work.
Oh, okay.
Like this one here.
Mm-hmm. I think so.
So I understand that when I put a capital S, capital F,
It's okay. Yeah. Maybe. I thought maybe that's it.
No, you just
Yes, please. Yes, HF underscore token in capital. Yes, please. Please, I stand to be corrected.
Can you show the name again?
Yeah.
This is HF underscore token, all caps.
Yeah, he tried it.
Yeah. Can you show it displayed on the just so that everyone is on the same page?
Please write this as your name for the secret. HF underscore token. All caps, please.
Regardless of what it's called in Hugging Faces.
Yes, please.
Yeah, it doesn't.
Yeah.
This is specifically so that when you use the Google Colab call, it knows that it's a Hugging Face token. So it doesn't matter what the token's called in Hugging Face. This is just so Google Colab knows it's a Hugging Face token.
Please, as much as possible, if you have any question, we can all help you in this hands-on training. This is Frank. He's from Midas. That's Nathan from Midas, and Nazreen. We're all going to work together to see how fast we can get you into speed with creating one, please. So you can call on their attention if you are lagging behind, please. Has everyone been able to? Yeah, just click this and then you close the X.
What I did actually is, so first I think this one is perfect, but just in case that somewhere as you find in the program is asking for this one, so what you can do is to add this here and then copy the same value to put it.
Because you've already.
And then,
Okay, you don't need to remember.
then you should be able to.
Okay, so so far, great, thank you. Okay.
It's like an online, no, it's like an online computational platform. So it's like a virtual machine hosted like, and then it runs like a Python notebook. So basically you run your programming language. And if you do this on your local machine, you should be able to also do this. You can, for example, like click file here, and then you can say, download to the IPYNB to local, and then you should be able to run the same. So Hugging Face is a hub that tries to collect models and it also provides the API that
He's getting an import
so
error.
that's like a RESTful system. Yeah, Google Colab is like an online computational. So instead, because why we did that on Colab is because when you are trying to configure a local environment to run this
Are we all here, please? Can we continue? Hello?
you do it in the ability to do it.
And so if you have created a secret token, then we, in this class, as much as possible and as fast as possible, we are going to try to create 2 single AI agents. The first is going to be a weathered focus AI agent, and then the next is supposed to be a data analysis agent. And so, from what we have expressed or explained in the tutorial section, the presentation, we're going to show you the framework of how an AI agent is created, using the model and then using the tools. The model in the sense of LLM, which is actually the brain, and then when you give it the tools to work, it becomes an AI agent. We're going to show you all of those structures as we go ahead. And so you go to the first cell, and then you click your Run button here. This cell will create the environments that you would need for you to start building your AI agent. And so if you click it, it is supposed to run to give you information. Yes.
How did you get to that page? Actually, yeah, how do you get scroll down in your
Scroll down in your.
page so to start the right panel?
Say again, please.
Right panel, how do you get to that?
Which of the panel, please? This? That's this?
No, the whole panel is blank. How do you get?
Have you accessed your email? It's sent, the collab is sent to your email. So please, if you click on that first cell, it's going to run to display this information for you. If you've done that successfully, you will get this output. Please, is anyone having any problem with this at this stage?
Yeah, I got that error. I got that same error. Dependency error.
Before that, we get a warning that the notebook was not authorized by Google.
Okay, that's strange.
That should be.
Yeah, I'm getting a warning.
Say again, please.
I'm getting a warning.
Okay.
It says this notebook's not authorized by Google.
Can I continue? Okay. If you run it successfully, it's going to display what is on the screen. If you've gotten to this stage, then we are good to continue. The next step is where you have the permission to activate your Hugging Face token. And then if you run this cell, which is, this is step 2. If you run this cell, it is going to ask you to paste that token.
The name or the key?
The key, the token key. And so you copy and paste it on this. Copy and paste in this cell. And then you press enter. Are we all there?
Yeah.
Okay. And then the next cell is going to help us to create the framework upon which our Hugging Face is going to be. We're going to, as much as possible, install or call in all the libraries that we need, all the large language models that we would need, all the tools that we would need. We'll bring it together in this next cell. We load as much tools as possible based on the tasks that we want our AI model to do for us. And so if you click this next cell, based on what we have listed here, it is going to call in the pandas, the matplotlib library, and then the seaborn. These are all libraries that would help us either in computation, visual outputs, graph plots. Those are the libraries that would need to create our AI agent. And so if you click on this next cell, it will run. If it runs successfully, it will tell you all the libraries are imported successfully. Are we there?
You're at step 3, right?
Yes. Are we all in step 3? Okay. So we move to part 1. This is where we start the main work. And it shows, if you can see, this box here displays the architecture of what our AI agents is going to be all about. We'll create a model. This model, or weathered agent model, is simply the brain, the LLM that we talk about. LLM without tools is just like a brain without legs or hands. It cannot carry out any tasks. And so the tools are like the legs and the hands or limbs that are given to the brain to execute its work. And so this is a model you will create, and then we'll create the tools that the model will use in this way. The next cell, which is like creating a weathered layer, weathered agents, is creating the tools first. We need to create the tools and make sure that the tools are working before we create the whole AI model. Trying to manage the errors or the debugging stages one at a time. You create your tools, you make sure you test your tools and make sure that they are working before you would run the whole AI agent. And so step 4, if you run that cell, it shows all the tools that we need, just like your search engine that would search for the weather information, your conversion tool that would help us to convert our degrees, convert information from degrees Celsius to degrees centigrade, or from degrees centigrade to degrees Celsius. That's the next tool. And then the final tool that would display or give us outputs. And so if you click on this next cell, it is actually a long set of code. And don't be scared. They are basically giving you a display of what kind of format that your output should be like. That is why it looks this bogus. They are simple, straightforward codes for you to understand. And so if you click on that step 4 cell, if it runs successfully for you, you would have a display of weather tool created successfully. Weather tool created successfully. And then you have a list of available tools like gather weather, convert temperature, and then compare cities. Are we all there? Okay. So we move to step 5. This is where we create our weather agent. Now we first create a model, which is the model inference client model. And then we create our agent by giving it the tools. That is when it becomes an agent. Tool 1, tool 2, and then tool 3. This is actually our AI agent, this part. And so if you run step 5, you run the next cell, I don't think this is supposed to be here. Frank. I don't think this cell is supposed to be, is it?
No, you can skip that.
Yeah.
I think I added one more testing thing. You can skip that too. Because I didn't know that this one connected to your notebooks.
Okay.
Like this one. The next one, you should delete that as well.
Okay.
That's my testing.
Okay. Okay. So it's not necessary.
Yeah, this one is not needed.
So are we all have we all run cell 5 under step 5? Yes, please.
Did you delete that one?
That's tiny cell. Yeah.
Delete that?
Yes.
And run the one below.
Yes, please. So if you run this cell 5 successfully, you will get a display at the bottom that says whether agent created successfully. And then you have this list. This is single AI agent with 3 tools, one brain AI model, 3 tools it can use, and then the same agent decides which tool to use. Are we all there? Okay. The next step is step 6, which is where we start to test our AI agent. Yes, please.
Even though I have that weather agent, it has the input request underneath it.
I think you should.
Weather agent, you discuss it, and there's another section that I didn't see the button.
I think you should delete the next cell. Yes, yes, import. Yeah. So if you run this step 6, the cell on step 6, we're trying to test our AI agent to see how it works. If you run it successfully, if you observe, it gives you the information stepwise as it's carrying it out. And then when it is done, it gives you the weather report. For this case, we are comparing London. And these are real-time information of the weather situation in London as at now. Are we all there? Okay. Yes. We're at step 7 right now, which is test weather agent, example 2. We've just finished testing the weather recall information. We're going to test how we're going to compare 2 values from 2 different cities. And so if you run the cell under step 7, you should have this information below. Yes, please. Thank you. Okay. It brings out the information between 2 cities that were highlighted or selected here. And then gives you an answer. Paris is partly cloudy with low humidity, 38%, and wind speed 12 kilometers per hour, while Tokyo is light rain, high humidity, 80%, and a stronger wind, 43 kilometers per hour. Yes, please. It's coming from the weather station information. Yeah. Yes, please. Oh, okay. I think it has to be your token problem also. So can I continue? We move to step 8, which is weather testing agents example 3. And at this stage, we're going to test to see how the weather agent can do the conversion for us. So if you run the cell under step 8, say again, please. Okay, I'm still running my. Maybe you could try to rerun it again. Yeah, I'm also getting the same no. So I think it's a problem. Can we continue because of time? Because we've almost exhausted our time limit. And so this cell which mine is still running, is supposed to compare the value of the weather situation for the two. Gets the weather situation for Dubai, converts the temperature to Fahrenheit, and tells if it is good for an outdoor activity. That is the task that we're trying to execute at that cell. So it will tell us whether the weather situation is favorable for an outdoor activity at Dubai. And so if it runs successfully, it would give us an answer telling us particularly this weather is favorable or this weather is not favorable for an outdoor activity. I think I'm still getting the same error answer. Please, can we go to the next step? Step 9. This is the interactive part of the AI agents. At this stage, we want to see how the AI agent can define, or if we give it tasks, what will be response to new sets of tasks that will give it. So if you run the cell under step 9, it will ask you, what is your question? At this stage, you can ask it any random question so that it doesn't feel like a pre-trained class up to this stage. You ask it your own random question and then you expect it to give you an answer. You can ask it, for instance, what is the weather situation at an hour today? So we're trying to get it to give us information about the weather situation at Ann Arbor today. And this is the output. I think we can do a quick verification on your phone to confirm if this is true by checking the weather information at Ann Arbor today, plus or minus some error. If you are connected, you can check your phone and verify some of these values. It will give you plus or minus some error with exact information because it's working on real-time data. And so you can ask it a next question. Any question from the audience, please? About weather. Any suggestion, please, from anyone?
Running weather in Paris.
Say again?
Running weather in Paris.
Okay. Running weather in Paris. Okay, it gives you a display. Temperature is 14 degrees centigrade or 57 degrees Fahrenheit. Condition is partly cloudy. Feels like 13 degrees Celsius or 56 degrees Fahrenheit. Humidity is that. Wind speed is 12 kilometers per hour. Wind direction is east-northeast direction. Visibility is 10 kilometers. And then ultraviolet index is 0. Can we try another question again from the audience? Another random question about weather situation in any city.
Ask it if it's raining in Dubai.
Okay. Okay, I think we have an error.
No, the scroll left on the horizontal bar. The horizontal bar. The scroll.
Weather situation in Dubai.
Oh, you have a typo. AI, not IA.
Say again, please, where?
It looked for the city Dubia, not Dubai. It's DUBAI.
Okay. What's the question again?
Is it raining in Dubai?
Okay.
AI.
Your AI is thinking. The answer is no. And then it gives you the weather situation in Dubai, which is displayed here. We're going to go to part 2 if you still have time, but I think our time is quite exhausted, and so you are free to go. But I just want to briefly tell you that The second part has to do with data analysis. This AI agent, the model is a data analysis AI agent that we want to create. You feed it with a data set. For instance, an information about a company data set like the profit, the sales, the income generated, the revenues, and the rest. You feed it with statistical tools such that you could load your CSV file. You could perform some statistical calculations like the mean, median, mode, and then create charts or histogram or bar plots from your results. If you are patient with me, we can go through this so that we will see that the difference between any single AI agent is just the tools. You have the same model, but different tools. And the tools is subject to the task at hand or task that the AI agent is meant to solve. And so if you follow me in step 10, you click the next cell to run, it will generate this set of data for us. We want to have this data just like a sandbox where we would create a separate or an isolated data bank that we're going to use for this process. So if you run that step 10 cell 10 under step 10, it is going to generate a CSV data bank for us that we're going to use in this stage.
Right access to that work?
No, please. Yeah, it's actually taking some time.
Can I just ask another question not related to any of this?
Yes,
Are
please.
you familiar with the U of M's the U of M's honey-based environment?
I'm not an expert.
Okay. Well, because I was just stumbling around and I actually got myself. U of M has a honey-based environment.
Yes.
And I was just going to play around, but I didn't want to break anything. I just found it, so I just thought, I didn't know if you had experience with it. So.
No.
Yeah, but it's got a lot of stuff. You didn't know who Yeah.
Yes, please.
Took me out of step 9 to get step 10 to work.
Oh, okay. Yes. You write quit to end this loop, please. Thank you for that. You write quit. And then it stops the previous step 9. Thank you. This is just to avoid the continuous loop that the AI agent will go through. Because if you leave it, it will continue to go over that loop over and over again. So for you to stop that loop, you type in quit. Or there was a setting we gave along the line to avoid it to go an infinite loop. We set it at 10 loops. So if you ask it like 10 questions, after 10 questions, it breaks. But if you want to break before the 10 questions, which is the 10 loops, you type a quit and then it stops. And so if you run cell 10 under step 10, successfully, it will give you a preview of the data set that was created. Are we all there? Okay. So we go to step 11, which is creating data analysis tool. We're going to create a tool that would help us load the CSV file, create a statistical tool that will help us calculate either mean, median, modes, and the rest. And then the third tool is going to be the visual tool, which will help us to display our outcome or results in form of graphs. And so if you run cell 10 under step 11, which is the tool that we have created for this type of agent. It's actually a long cell. So if you run it successfully, it will tell you data analysis tool created successfully. So if you move to step 12, which is create data analysis agent, and you click the next cell, if it runs successfully for you, it's going to show creating AI model for data analysis, creating data analysis agents, data analysis agents created successfully. And so we're going to test our data agent under step 13, which is example 1. If you run that cell, it is going to load your CSV file. And if you do that successfully, you would see the first 5 lines and then the first 5 rows, and then the last 5 rows from your data. This is just for visualization. Are we all there? Okay, we'll go to step 14. Test data agent example 2. If you click that cell, we want the cell to calculate the statistics for sales for the columns of sale data. And so it gives us statistics at the bottom, which shows statistics for sales. So if you go to step 15, testing the data agent example 3. If you click on that cell, it is going to create a bar chart and sales column, bar chart for the sales column for us. And if you do that successfully, you're supposed to have a display like this. And so if you move to step 16, data AI agent example 4, if you run that cell, it is supposed to show us a line chart for the profit over time. If you do that correctly, you will have a display like this. And then you go to step 17, which is testing our AI agent. If you run the cell under step 17, where we ask it to load the data cell, calculate the statistics for profit, and create a histogram showing the distribution. This is a more complex task. And so it would give us the information requested for that cell. It is still running or executing here. And so the next cell, which is 18, is for us to try random questions about how our data analysis AI agents can perform. So at this cell, which is cell 18, if you run it, it will ask you for a prompt, a question. What do you want to do with your data analysis? Any suggestion from the audience, please? Which month has the highest profit? So as we wait for it, it brings us to the end of this coding system for the AI class. It's giving us an error. Output is none. Okay. Okay. I think I have exhausted my token usage for so the most important thing is for us to have an idea about the fact that for both the weather agent and the data analysis agent, we have a model and then a tool. And the tool is built, or the choice of tool is based on the specific tasks that you want your model to execute for you. You cannot ask a statistical AI agent to give you weather information. It is going to tell you error because it was not built for it. Even if the LLM will have a weather information to give you, it will tell you that it is not built for such kind of tasks. And so if you give the right tools to the model, it's going to give you your expected output. So that's just the beauty about this AI agent thing. You can build it as much as possible. It's unfortunate that we can't show you how the multi-AI agent system works because there's no time for that. I will liaise with the organizers of this if we could share such collab for you through your email. It will be made available for you. For you to build a multiple AI agent system, you start by creating single AI agent system. Once you perfect them, you combine them together to form the multiple team. That's the easiest way for you to manage your error. If you go ahead to build a multiple AI agent system all at once, it is going to give you a lot of challenges because you have to debug and continue to debug for as long as you are not getting one step right or the other. So the easiest way is just like building this single AI model. You try creating your tools, you run your tools, make sure that they are perfect, and then you put them together to run with the model to form the agents. And so for multiple AI agents situation, you create each individual model, you put them together to work as a team, you create your multiple AI agent. It is more complex, but it could give you, it could save you a lot of time. It could save you a lot of man input hour, but it is worth it. And so we are only here today to give you a concept of what an AI agent is all about. It is left for you to go further step to see how you could build on it. If you find it, if you have any challenges along the way, you can contact any one of us in the Midas unit. We'll be so glad to put you through in this. So thank you, unless you have further questions, please. Please remember to give your post-event survey, please. Yes, I think I know her. Yeah, I know her.
You got a big community. I'm just wondering, what is the difference between an agent with multiple tools and an agent with one tool, but there are multi agents? What are the differences between the two?
Like, if you have a single AI model,
It's just
But if you have a multiple AI system, feed it with different types of just like research on this question of we may research on pharmaceuticals. Worry about what's going to happen. Give me information about biomedical. Yeah, right. That agent will take care of that. And if they are supposed to work together in collaboration, they put information from different fields. But for a single AI agent, you must not be able to feed it with tools from pharmaceuticals and biomedical.
But what if I have like two tools? One tool is for specifically for the biomedical, another is for like another field. I have also like one field with two tools, right?
It's going to work like that. As long as you define specific tools for the specific types.
But it's still different for multi-agent.
Yes, it's different.
So as far as I understand, it's more like
no, because like the multiple agents, you have to give it a model with a specific tool. You can create one set of models specific to create another set of models with a specific tool. And then you combine all of them together. They work as a system. But for the singular AI model, it's just the number of tools that you give to it varies. So that it's simple to manage a single AI. Complex one is actually very
that's the reason we will have like a single agent.
Yeah. The multiple is actually very complex. If you don't train your single AI model properly, you can combine it from the multiple agent.
Or still a single agent, so like a starting point.
But if you really want to use an API, you have to have a shortcut for us.
What's your major? Also like a deep learning for drug discovery or like
what? I just started AI just last year.
Okay.
I'm specialized in geophysics.
What?
Geophysics.
Geophysics. Oh, so it's more like pretty interdisciplinary with the AI for different like areas.
I'm actually applying it on remote sensing data and then ground geophysics nationals. I'm trying to see how I can train a model that will be perfect to identify some
I'm majoring like in medicinal chemistry, pharmacy, so we kind of want to speak lines.
That's good because I know that there's a lot of input right now from is it drug creation using machine learning?
Yeah, but for me, I'm more like doing the reaction optimization. When we want to manual synthesize a drug, we wanted to make the reaction more efficient. Somehow.
Nice meeting you.
Thank you so much.
Yeah, what's your name?
Tiger.
Tiger. Wow, okay. I'm Joseph. Frank, thanks very much.
Yeah,
really appreciate it.
Yeah, I think you did a great job.
Thank you.
Because I know this hands-on sessions is online.
Okay.
I was telling
This is my first time of being in an audience like this.
Yeah, and I think you handled it really well.
Okay, thank you. I really appreciate it, and thanks for your support.
Yeah,
It's really, you saved me with that talking, because just like this situation of being exhausted with talking time use, he gave me his own talking.
IPI is also like affiliated to the team, so that his name is